So today we're going to be finally looking at the insides of the PDSSAP 20 lithium impact. We've tested this little impact driver before. We've had very good results on its capabilities with driving bolts and screws and lug nuts and everything of that sort. But let's have a look what's inside. So we have a bunch of Phillips screws on the outside, this backing plate with, again, a couple of screws, and then we have some hex head Allen screws holding in the impact driver section. So let's get started with pulling off some of these screws. So just off this side panel, we can just use our trusty little driver here just to pull out these screws. Now, I'm expecting this to be fairly similar to the drill series that the Performance lineup has. I'm quite sure they share the same trigger module and that the brushless motor controls are going to look quite similar, since it's obviously all coming from the same manufacturer and similar designers. So now that we've gotten these screws free, we can pull off this back plate that is covering the brushless motor section and the fan. So quite a few screws, but that'll help keep the tool nice and steady and rigid in use. So let's see if we can pull off this back plate. Yes, there is a bearing in that plate, so yep, that'll just take some pulling, and as you can see, we've actually pulled off the rotor assembly out of the motor. So there is a bearing carrier on the back here that's holding this bearing. It's fairly tight in there, so I'm not going to force it. As you can see, we have this spline shaft coming out of the rotor that is going to be driving the hammering mechanism. A nice little red fan on here. The permanent magnet rotor, you can actually see the 4 magnet poles set up inside there and a liberal dose of grease, which is also good to see. In the back, of course, we have our motor. We have some Hall effect sensors peeking out there. Let me just get some additional lighting on here that I've forgotten. Let's see if I can give you guys a decent view of that. We had it here. So there you have the insides of that. We'll get into that closer once we get the rest of these screws out. As you can see, plenty of grease to be had in there. So I think we've pulled off enough screws to split this case, but let's pull off our hex head screws to liberate the driver section. So all of these are plastic self-tappers, not much to be done about that. And this type of device, I'm sure all the other manufacturers are basically using the same system. Some nutserts in the plastic or something and some machine thread screws would have been nicer, but this is obviously never intended to come apart, so I guess that is a viable option. So let's see if we can pull this side panel off. Oh, we might have forgotten a screw somewhere in here. Let's make sure all these are nice and loose once we have the correct bit installed here. So, okay, let's just pull most of these out while we're at it. Won't be spreading them across the floor. So that should be pretty much everything that's holding this on. Let's see if we can get this last pesky screw removed. There we go. Cut that in midair. So here we have all our screws out, so quite a number there. And let's try and pull off what, oh, we still have one hiding at the top. So hopefully that should give us sufficient access to the insides of this. Interestingly enough, this long one is different from the others. So that looks to be all the screws I can really see. Hopefully this will allow us to extract this thing. So, okay, we have some movement on the motor drive section. Oop, there we go. Here we have the whole hammer assembly and gear train coming out as one piece. And let's see what's holding us up here in this motor drive section. I believe we have all of the screws that are necessary. I don't want to break something. Let's see, maybe this screw for the bangle is holding us up somehow. Let's see, remove that. And we still do not have separation. Let's see, maybe some, whoops. There we go. That didn't sound too good, but doesn't look like anything's broken. So there might have been a touch of glue holding, I guess, maybe the battery compartment together. As you can see, nothing broken on here that I can see. There is some kind of glue residue here, so maybe that was just holding us up. So our standard design, let's see if we have any markings here. Yes, we do. PA6 30% glass fiber reinforced, standard nylon construction, and then we have this TPU overmolding that is very comfortable to the hand. Nothing too exciting to see here. We do see that there is a bit of wear on this rear bearing. Let me just think how that would sit. So let's see, the motor sits like this, so that seems to be wear. As you can see, there is quite a bit of wear on this never before used tool. I guess that's just from factory testing, but that overlaps with the motor there, so I don't really see how that could have been wear from actually running the motor. Maybe they had to file this down in the factory just to get it to fit, because as you can see, it's just the outer stator that sits against that, so there really is nothing to wear in that area. So back to the control section, we can just put this side apart. We have our standard PCB control on the bottom here. If you remember, on the hammer drill, this was integrated as a plate on the back of the brushless motor. Here we only have this small PCB that has just the Hall effect sensors, and you can actually see it's marked Hall board right here. So that is just doing the rotation detection and the phase. Most of the control is happening down here. We can pull off this LED cover. Oops, there we go. We have this tiny, like 3mm LED in there. And then hopefully we can remove the PCB. Yep, there we go. So that just slides into a slot at the bottom here. We have our 3 contacts for the battery connection. Some of them falling apart a little bit just on the overmolding. This has all been encapsulated with your typical black goop epoxy to hide everything. Unfortunately, there doesn't seem to be much accessibility to the PCB since it's all been encapsulated here. We have our couple of wires going to the brushless motor. Of course, this is probably a 3-phase, so yeah, we have 2, 4, 6 poles, so we have a 3-phase brushless motor, so we have 3 lines for the 3 phases, and then we have some so here we have these thicker 3 wires will be our 3 phases to the motor, and then on these wires we have our Hall effect sensor returns and probably a power and a ground. So this leftmost connector here that's been siliconed in is carrying the Hall effect signals from the brushless motor. The 3 thicker wires we have here, black, red, and red, are the 3 phases driving the motor, and then we have these other, let me see, 3, 4, 5 wires driving the trigger, which interestingly enough again is the same trigger we had in our hammer drill. So let's see if we can read that. FA2-16/1WEK 42 volt DC 0.2 amps. This is very interesting since it is the identical trigger module as in the hammer drill, and I've been doing some research into this, and I think I have a very easy hack hack to remove our sleep or protection mode that we've been talking to earlier, where you have to hold down the trigger. Stay tuned. In the next couple of days, I will be releasing a video where you can remove this sleep mode very easily with a 5-minute hack. So here we have our motor basically just falling out of the case. So again, you can see it's sitting in this little area here. No plastic chafing on this side, although we do have a little bit of filing here. So I think both of those sort of artifacts are factory filing just to get the fit. There's no moving parts there that would actually cause any of that plastic to come off. So interestingly enough, we do have a marking here on the motor. I'm not sure if you can really see that. I'm having difficulty reading it myself, but again, it is a BL5210 20 volt Parkside Speedmaster. So this is the same brand, I guess, of brushless motor that was on the hammer drill, obviously a much smaller sized one. We have our 3 brushless inputs going on there, and then here we have a possibly better look at the brushless or the Hall effect PCB. Let me see if I can pull off the PCB itself, then we can have a look at the Hall effect sensors themselves. So again, just 3 of these little pan screws that are holding the Hall effect sensor board to the stator. Let's pull these off. And that leaves us with our brushless motor. As you can see here, fairly nice and compact, very powerful for its diminutive size. And here we have our Hall effect board. Really nothing more on there than our 3 Hall effect sensors and some resistors going into this wiring here. Just a single-sided board here. You can see the silk screening on there. Again, nothing too interesting, 2 power inputs and 3 Hall effect returns. So we have our 5 volt, a ground, and our 3 Hall effect outputs coming out there. Again, to the bottom control board, we have our encapsulated torque selection button here. I might be able to pull this off. I might not be. Oh, there we go. So this plastic cover just comes off, and then we have our rubber molded button, and we have our torque sticker just coming off here. And down in there, we actually have our little press button. You might be able to see that there. And we have our green LEDs in these little wells that are doing the indication of the torque. On the board again, we have our sort of heat sinks peeking out here. We have our capacitor on the input there. We really can't see what kind of MOSFETs are in here, what kind of switching they're doing. This will have to remain a mystery. Here we still see the programming port that they used at the factory to program the board in the microcontroller, but this is all really well potted. It would really be an effort to get in here. We see the markings again, plus, minus, and the T-pin. As I've shown before, this is the battery communicating to the tool if it's okay in working order or not. So we can put the motor to the side, and let's have a look at the hammer mechanism. I'm not sure we're going to be able to get in here very much. We have our 1/4 inch hex drive on the output here, all nice solid aluminum, all machined, as you can see, just one solid piece throughout the head. And then we have our drivetrain here. You can sort of just see the orbital drive gears in there. I'm not sure how this really takes apart. Okay, so it's spinning, so maybe we can somehow coax it out of there. Just give me a second and I will be back once we've gotten this disassembled. So I've been to work on this just with a flathead screwdriver, just sort of pushing and turning on these sort of nylon indents. And when we sort of push this plate up, I believe it's indexed for this sort of flattened area to correspond to the one here. We can pull that plate off. We can see there is an O-ring here keeping the grease-filled hammer system sort of protected from dust and whatnot. So here we have a fairly big ring gear and our bearing, nicely large size, that's retained in this nylon cap just to keep the impact mechanism centered. Now the whole thing is loose, so I think if we, let's see here how this comes together, we can, whoop, okay, here we go. So you just sort of tip it up and the whole mechanism falls apart. So we can see here the impact head hidden down in here. More importantly, here we have our bearing. Through it goes the rotor spline shaft that interfaces here with these planetary gears, and those in turn, I guess, rotate. Yeah, they rotate this anvil piece, I guess. So let's see if I can get this aligned correctly. Just bear with me. So yeah, so the rotor spins. This ring gear is actually held solidly in place in these retention holes, in these 6 retention holes in this casing. So the ring gear is fixed. The brushless motor rotor turns. This spins the planetary gear set in here, which in turn then spins this massive anvil. And I mean, this definitely has some weight to it. There's of course this spring that sort of handles the recoil of the hammer, and I guess it's probably pinned inside here with this hex head shaft. I'm not sure I can pull that off, but as you can see in here, we do have our, let's see if we can get a decent view on there. There we have our hammer that's just spinning on its own bearing at the depth of this aluminum head, and it is being impacted by this anvil here. These 2 teeth, they strike that T-shaped head, and they compress this massive spring they have on here. It's quite the spring force, and it sort of recoils on this spring and keeps turning, impacting the head. We can see here this front area just locates inside the hammering piece, so that is retained on there, just in the center. Just in the center there, this central hub is just being set and held in place as a bearing, and these outer 2 teeth on the anvil impact the head and make it spin and turn and transfer that massive torque onto the workpiece. So plenty of grease in here. It looks well lubricated, looks very decent. We have a nice sort of bearing system on here. Definitely fairly sturdy construction. I don't really see any pieces that would wear that much. This material here seems to be sintered steel, but certainly this is massive enough not to suffer any substantial wear. I guess the major wear would be on the sides of these teeth here, where it would wear out to a sort of diagonal cut where the impact wouldn't be transferred that efficiently, but this is definitely sturdy enough to resist such failure. So yeah, that's pretty much it. We can see on the guts and the insides of the smaller 1/4" impact, certainly well built, nice sturdy aluminum casing, plenty of grease and lubrication on it. We have very good sort of bearing and retention system to hold everything in place. So yeah, there we go. There's this just front bearing off the rotor that just keeps, I guess, the front of the motor steady. So yeah, all in all, very sturdily built device. certainly, definitely worth the price, definitely a leading tool in this category. Well built, as we've seen before. The Parkside Performance tools have always been very sturdily built and solid. So I hope you've enjoyed this video, and if you would like to show your appreciation for the hard work that goes into making these videos, consider hitting that subscribe button, and that will make me want to continue making these videos and also give the YouTube algorithm an idea that people enjoy this type of content and recommend it to other people, and that's purely a win-win. So keep on doing that. I hope you come back on the next one. As I said, I'm going to show you how to hack and bypass the sleep mode that affects the trigger here. So come back for that in the next couple of days. Otherwise, thank you for watching and see you next time. Bye-bye.